Our next speaker is Musab. Amazing name. Musab. I told him he should be an Arab anchorman, rather. He should be a rock star with that kind of name. But he's something even better, an architect. And he's from Jeddah. He's now a graduate student at the University of Pennsylvania. Please welcome Musab to the stage.
Hi, everyone. First of all, I'm glad to be here, and I'm grateful for this opportunity. I'm going to talk about advancement of technology in design and fabrication. But before I start, in my undergrad, when I started as a computer engineer. From the first class of Java coding, I just hated it and I moved to architecture. I'm going to come back to this point very later. I enjoyed my study in undergrad as an architecture, and when I applied to here and I started my architecture degree, it was very informative, beyond what I expected, and I learned a lot through this. I assume most of you, when they were coming here, they just Google Map the Plaza Hotel, you got the red pin and followed that. If the hotel is represented by a pin on a map, so what if we moved the Plaza Hotel, for example, to Philadelphia? Would that make a difference? I don't think so, because you're just going to follow the pin. So that triggered a question of research of my last year at the school. What if we can actually build a house that is relocatable, so you could take it anywhere with you? That sounds really crazy and ambitious. But this is how things kind of start. So we started to looking if we design this little tiny house as an experiment. How are we going to deassemble it and move it and do all that? So I felt lazy. Laziness sometimes is good because it tells you the easiest way to make something. So we said, why it's not a floating house? So just room in the water, literally. So we started working on this idea, but we have a lot of constraint, the weight, the material. But it's a house. We wanted to use a concrete and deal with the concrete as if it's a very lightweight material. So that's where computation and design came in process. So we tried to have a very geometric shell that self-sustains itself as a house, and it's a light, and it could resist the water. So through our research, we found a lot of interesting materials that could work with the concrete. We finally managed to have this kind of house structure. It's 7 times stronger with almost less material than the usual building, by 4 times, and it's only 2 inches thick of the wall. So this 2 inches thickness, which is 5 centimeters, is just holding the whole structure. Then, once we kind of figured that out, we thought okay, what this could do in our daily life. Instead of living in land, we could inhabit the water. So you're literally living in the water. If you want to take a break, if you just by small town or cities, or even if you just get annoyed by your neighbor, just go away to another neighborhood and just enjoy your time. So this is kind of a city versus a city, and it's totally different topology. There's no roads, so either you're going to swim or, I don't know, go with the house. And also you could assemble a couple of houses in front to have a yard, and then you have your front window open so you can literally go outside, enjoy the weather. We looked into specific cases in Venice and London, where kind of living boats taking place. So it's not in open water, it's in small, tiny river bases and lakes. This house, as the way it's been designed, is kind of really advanced tech. So we have integrating all of the Internet of Things and this technology. So the house, it reads when you come to the house, so just the lighting, the temperature, is integrating Alexa on every aspect of the house. And it's a driverless house or autonomous. So you just pick up the location that you want to go, and it will just drive its own. I think it's a little bit more safer than Uber autonomous car that hit a lady last week. So in order to do this kind of complex geometry, normal ways wasn't helping a lot, because in order to just make the last piece formwork on this scale, it would take up to 3 days. We just managed to do it in 3 minutes. So what we're doing, we're just cutting the styrofoam pieces to make a formwork for the concrete casting, and then we just cast the concrete and take it out of it. Human versus machine. We understand how the machine works, but it doesn't understand. It does what it does unless we tell it. So no problem that robots are going to take over the place unless you install artificial intelligence without any constraint. So we tried and worked, and we managed to get these thin shells in many different forms, structurally stable, standing on their own, even though kind of dividing the whole kind of geometry into pieces, so when you put them together, they align one single geometric piece. And we've been doing some tests with concrete. Just we're trying to get the concrete to do something it's not supposed to do. That's like one of the second researches that we've been doing. And then after I finished this project, I was told, like, if you're willing to join us as a research assistant at the lab. So I'm doing this as part of my OBT right now. And the house should be constructed over the summer, but there is no rules for on-water housing or residency. We were that crazy. So we went to the second project from the class to do that, and I have the chance to oversee and observe the robotics production for this house. Then another project coming. We are just looking into the most ancient basic material, the clay, so instead of using it as bricks, we just 3D printing the clay in different ways. So there's a couple of tests that we tried to make. We're just trying to get it straight up to see the structure and the stability of it. And afterwards, we're trying to test some kind of inclination with separate geometries. And that expected to be like working with concrete and other material, like such as plastic or even sand printing. All of these technologies allow us to produce more with something that's really cheap. So environment friendly, economical, and it's easy, and you don't even need a human factor actually to be on the site if it was like a dangerous location on a mountain or in underground or something. So if you have the robot could build the thing, then you can have the robot on autonomous car. So you just specify the location, have the program ready, the vehicle will go to the site, it will start construction and just go back when it's done. So talking about this advancement of technology, as an architect and designer, we use these tools in our field. Other people would use it in different fields, in medicine or such. But this is groundbreaking in the way that what gets produced. So most of this research is just taking place on small scales, as a pavilion or a house, as you mentioned. And speaking of the Vision 2030, even New York City and all this kind of economic city that's coming, part of that is teaching this kind of advancement of technology. But what if this to be part of making this vision happens? And all of these, I wouldn't say it's like a future. It's happening now at the moment. And even if it's a future, this future is not that far. And the proof of that is only in 2 days, tomorrow will be yesterday. Thank you so much.